Salam and welcome to the second presentation on the Entity Relationship Modeling for CIS 3107 Database Modeling. We will be discussing entity relationship diagrams, which is covered in section 4.2 in our text. In this second presentation, we will learn how relationships between entities are defined, refined, and incorporated into the database design process. Recall from Unit 2 that a relationship is an association between entities. The entities that participate in a relationship are known as participants, and each relationship is identified by a name that describes the relationship. The relationship name is an active or passive verb. Entity relationships may be classified as one-to-one, one-to-many, or many-to-many. The term connectivity is used to describe the relationship classification. Cardinality expresses the minimum and maximum number of entity occurrences associated with one occurrence of the related entity. In Figure 4.7, a professor teaches a class. In the ERD, cardinality is indicated by placing the appropriate numbers beside the entities, using the format of parentheses x, y, and parentheses. The first value represents the minimum number of associated entities, while the second value represents the maximum number of associated entities. Keep in mind that the cardinalities represent the number of occurrences in the related entity. The cardinality, parentheses 1, 4, and parentheses next to the class entity in the quote, professor teaches a class, end quote, relationship indicates that each professor teaches up to 4 classes, which means that the professor's table's primary key value occurs at least once and no more than 4 times as the foreign key values in the class table. When the specific cardinalities are not included on the diagram in crow's foot notation, cardinality is implied by the use of the symbols shown here in Table 4.3, which describe the connectivity and participation. Remember that the n represents no upper limit. An entity is said to be existence dependent if it can exist in the database only when it is associated with another related entity occurrence. In implementation terms, an entity is existence dependent if it has a mandatory foreign key, that is, a foreign key attribute that cannot be null. If an entity can exist apart from all of its related entities, then it is existence independent, and it is referred to as a strong entity or regular entity. For example, suppose that the XYZ Corporation uses parts to produce its products. Furthermore, suppose that some of those parts are produced in-house and other parts are produced from vendors. In that scenario, it is quite possible for a part to exist independently from a vendor in the relationship. Quote, part is supplied by vendor, quote, because at least some of the parts are not supplied by a vendor. Therefore, part is existence independent from vendor. The concept of relationship strength is based on how the primary key of a related entity is defined. A weak relationship, also known as a non-identifying relationship, exists if the primary key of the related entity does not contain a primary key component of the parent entity. By default, relationships are established by having the primary key of the parent entity appear as a foreign key, FK, on the related entity. A strong or identifying relationship exists when the primary key of the related entity contains a primary key component of the parent entity. The database designer determines which relationship type and strength best suits the database transaction, efficiency, and information requirements. In Figure 4.8, a weak relationship exists between course and class because course_code, the primary key of the parent entity, is only a foreign key in the class entity. In this example, the class primary key did not inherit a primary key component from the course entity. The crow's foot notation depicts a weak relationship by placing a dashed relationship line between the entities. In Figure 4.9, the class entity primary key is composed of course_code and class_section. Therefore, a strong relationship exists between course and class because course_code, the primary key of the parent entity, is a primary key component in the class entity. In other words, the class primary key did inherit a primary key component from the course entity. The crow's foot notation depicts the strong or identifying relationship with a solid line between the entities. In contrast to the strong or regular entity, a weak entity is one that meets two conditions. The entity is existence dependent. It cannot exist without the entity with which it has a relationship. Secondly, the entity has a primary key that is partially or totally derived from the parent entity in the relationship. The database designer usually determines whether an entity can be described as weak based on the business rules. In Figure 4.10, a company insurance policy insures an employee and any dependents. For the purpose of describing an insurance policy, an employee might or might not have a dependent, but the dependent must be associated with an employee. Moreover, the dependent cannot exist without the employee. That is, a person cannot get insurance coverage as a dependent unless the person is a dependent of an employee. Dependent is the weak entity in the relationship. Quote, employee has dependent, end quote. Figure 4.11 illustrates the implementation of the relationship between the weak entity, or dependent, and its parent or strong counterpart, employee. Note that dependent's primary key is composed of two attributes, imp_num and dep_num, and that the imp_num was inherited from the employee. Given this scenario, and with the help of this relationship, you can determine that Janine J. Califant claims two dependents, Annalise and George. Keep in mind that the database designer usually determines whether an entity can be described as weak based on the business rules.
Optional participation means that one entity occurrence does not require a corresponding entity occurrence in a particular relationship. Mandatory participation means that one entity occurrence requires a corresponding entity occurrence in a particular relationship. If no optionality symbol is depicted with the entity is assumed to exist in a mandatory relationship with the related entity. For example, in the, quote, course generates class, quote, relationship, you noted that at least some courses do not generate a class. In other words, an entity occurrence or row in the course table does not necessarily require the existence of a corresponding entity occurrence in the class table. Therefore, the class entity is considered to be optional to the course entity. In the crow's foot notation, an optional relationship between entities is shown by drawing a small circle on the side of the optional entity, as illustrated in Figure 4.13. The existence of an optional entity indicates that its minimum cardinality is 0. The term optionality is used to label any condition in which one or more optional relationships exist. Quote, each course generates one or more classes, end quote. In ER terms, each course in the, quote, generates, end quote, relationship must have at least one class. Therefore, a class must be created as the course is created to comply with the semantics of the problem. This mandatory participation is depicted graphically as a small hash mark across the relationship line, similar to the crow's foot depiction of a connectivity of 1. The existence of a mandatory relationship indicates that minimum cardinality is at least 1 for the mandatory entity. A relationship degree indicates the number of entities or participants associated with a relationship. A unary relationship exists when an association is maintained with a single entity. A binary relationship exists when two entities are associated. A ternary relationship exists when 3 entities are associated. Although higher degrees exist, they are rare and are not specifically named. For example, an association of 4 entities is described simply as a 4-degree relationship. In the case of the unary relationship shown in Figure 4.15, an employee with the employee entity is the manager for one or more employees within that entity. In this case, the existence of the, quote, manages, end quote, relationship means that the employee requires another employee to be the manager. That is, employee has a relationship with itself. Such a relationship is known as a recursive relationship. Binary relationships are the most common type of relationship. In fact, to simplify the conceptual design, most high-order, ternary, and higher relationships are decomposed into an appropriate equivalent binary relationships whenever possible. In the figure, quote, a professor teaches one or more classes, end quote, represents a binary relationship. The use of ternary and high-order relationships allows a designer some latitude regarding the semantics of a problem. A ternary relationship implies an association among three different entities. In the figure, note that the relationships and their consequences, which are represented by the following business rules. Quote, a doctor writes one or more prescriptions, end quote. Quote, a patient may receive one or more prescriptions, end quote, and, quote, a drug may appear in one or more prescriptions, end quote. We have just learned a recursive relationship is one in which a relationship can exist between occurrences of the same entity set within a unary relationship. For example, in figure 4.17, a one-to-many unary relationship can be expressed by, quote, an employee may manage many employees, and each employee is managed by one employee, end quote. A one-to-one unary relationship may be expressed by, quote, an employee may be married to one and only one other employee, end quote. Finally, the many-to-many unary relationship may be expressed by, quote, a course may be a prerequisite to many other courses, and each course may have many other courses as prerequisites, end quote. Many-to-many relationships are a valid construct at the conceptual level, and therefore are found frequently during the ER modeling process. However, implementing the many-to-many relationship, particularly in the relational model, requires the use of an additional entity, as you learned in Unit 3. The ER model uses the associative entity to represent a many-to-many relationship between two or more entities. This associative entity, also called a composite or bridge entity, is a one-to-many relationship with the parent entities and is composed of the primary key attributes of each parent entity. May also contain additional attributes play no role in the connective process. Note the composite enroll entity in figure 4.23 is existence dependent on the other two entities. The composition of the enroll entity is based on the primary keys of the entities that are connected by the composite entity. The composite entity may also contain additional attributes that play no role in the connective process, such as the grades, absences, and other data uniquely identified by the student's performance in a specific class in the enroll entity. Keep in mind that the enroll tables key, class_code, and stu_num, is composed entirely of primary keys of the class and student tables. Therefore, no null entries are possible in the enroll table's key attributes. Because the many-to-many relationship between student and class is decomposed into two one-to-many relationships through enroll, the optionalities must be transferred to enroll as shown in figure 4.25. In other words, it now becomes possible for a class not to occur in enroll if no student has signed up for that class. Now that a class need not occur in enroll, the enroll entity becomes optional to class. Also, because the enroll entity is created before any students have signed up for a class, the enroll entity is also optional to student, at least initially.
In summary, the ERD includes connectivity and cardinality notations and can also show relationship strength, relationship participation, which are optional or mandatory, and the degree of relationship, such as unary, binary, or ternary. Connectivity describes the relationship classification as one-to-one, one-to-many, or many-to-many. Cardinality expresses the specific number of entity occurrences associated with an occurrence of a related entity. Connectiveness and cardinalities are usually based on business rules. In the ERM, a many-to-many relationship is valid at the conceptual level. However, when implementing the ERM in a relational database, the many-to-many relationship must be mapped to a set of one-to-many relationships through a composite entity. Thank you for viewing our Unit 4 Part 2 presentation. The diagrams and content of this lecture are derived from our textbook. For a more detailed treatment of these concepts, please review pages 124 to 140 in our text.